Can you imagine traveling hundreds of miles in the time it takes to watch a TV show? No engine roar, no friction, no wheels grinding on metal. Just a train that glides effortlessly above the track, accelerating faster than a sports car. This isn't science fiction, it's real, and it's called magnetic levitation, or maglev. Unlike traditional trains, maglev trains don't have wheels at all, they float. Powerful magnets in the train and the track repel each other, lifting the entire carriage several millimeters into the air. With no physical contact, there's almost no friction. This allows them to reach incredible speeds, far beyond what conventional rail can ever achieve. Japan is leading the charge. Their LO series maglev has hit test speeds of over 600 kilometers per hour. That's faster than many planes during takeoff. And the craziest part, when you stand beside the track as it passes, it's almost silent. There's no engine noise, no shaking, just a soft, gentle whoosh as it slices through the air. The idea is simple, but the science is sophisticated. One set of magnets lifts the train and another set propels it forward. Electromagnets in the guideway switch on and off in a perfectly timed sequence, pulling the train along at an astonishing rate. Because nothing ever touches, wear and tear is minimal, meaning lower maintenance costs and smoother, more reliable journeys. One of the biggest perks of maglev is its energy efficiency. At high speeds, friction is the biggest energy drain for a regular train. By eliminating it, maglev needs far less power to stay at top speed. In fact, for long distances, the energy used per passenger can be lower than an airplane or even a standard high-speed electric train. The real promise here is the future of long-distance travel. Imagine boarding a train in London and arriving in Manchester in just half an hour. Imagine replacing domestic flights with clean, quiet, super-fast rail. Some even envision maglev systems connecting entire continents, creating congestion-free corridors for travel. Of course, there are challenges. Building a maglev system isn't cheap. You can't just upgrade old tracks. You need to build entirely new, precisely aligned infrastructure. The engineering is complex, and the initial cost is high. This is why we haven't seen maglev lines pop up everywhere just yet, but the long-term benefits are undeniable. Maglev trains produce zero direct emissions. They offer a level of speed and comfort that traditional rail just can't match. As the world pushes for greener alternatives to air travel, maglev is getting a serious second look. There's even talk of combining maglev with vacuum tunnel systems. If you remove air resistance on top of friction, a train could theoretically reach speeds over 1,000 kilometers per hour. This concept, known as evacuated tube transport, is still experimental, but it hints at a future of near supersonic ground travel. For now, though, maglev is already impressive enough. Step inside one, and the difference is immediate. No rattling, no clattering, no sudden jolts. The acceleration is smooth and constant. It feels less like a train and more like a floating lounge gliding through the landscape. What seemed like a far-off dream 20 years ago is now a reality in countries like China, South Korea, and Japan. As the technology gets better and cheaper, more nations will likely get on board. Magnetic levitation is a powerful reminder of how engineering can completely reshape our world, offering a faster, cleaner, and more sustainable way to travel. Maybe sooner than we think, those long drives and short-haul flights will be replaced by a simple, silent, floating train. Thanks for watching. Follow Tech Obsidian for more deep dives into the science shaping our future.